Well, there's our voltage coming up here now, all spectacular and everything. We've got the negative on the top, positive on the bottom, and that can't be right. That is absolutely weird. What are you doing to me? Don't tell me it's died already. What? That's no good. 2.9. We'll just take that off for a second. Something's going on here. I think we're running at a massive failure. Oh no, I'm so depressed. Was that 0.8? Why was it showing so little? That's 0.8 from 1.5 down to 0.8 in the time it makes a cup to make a cup of coffee. Alright, we've got 3.84 in the battery. We'll just plug that back in again. See, we've got negative on the top side there. Just turn that off. Well, that's very, very not good. Is that called very not good? That's a scientific term for, oh my god. Yeah, so, sorry folks, it doesn't seem to have worked. It doesn't seem to have worked at all. I'm not very happy about that. Yes. So, cheers, have a cuppa. We'll do some more research into that. That is a mobile disaster, ladies and gentlemen. Oh my goodness. Why did it... I don't know what's going on there. It should have done better than that. Why does it hate me? Turn the power on that again. Just have a quick look. Yeah, 1.4. And how fast does it drop? I can't be I don't know. That seems to hold better than the last one did. Maybe it needs a few cycles to come up to goodiness. I really would have liked to see 1.8 volts, but I think that's a little grubby in that I've got graphene floating in the top, graphite floating in the top, and it might be shorting out somewhere, but I don't know. I don't think it can, because the electrode is on the bottom and this electrode is on the top, and the graphene, there's no connection between the two, although a cleaner jar might help. I can't seem to see the brownish or the yellowish zinc bromide forming at the bottom, but yeah, I think I'll make a new one, a big one. We'll start off with one. I don't know how much water it's going to take. I'm going to have to measure it, fill it with water, and then drain it out and see how much I've actually put in it. This is demineralised water. It seems that in Australia you can't get distilled water. So the water distilleries have gone broke, I think. No good. Demineralised water. So I don't know if it's got any chemicals in it, but I hope not. Well, that's about it. Do I sound disappointed? I am. I am slightly disappointed. Yeah, slightly indeed. I've got a few things to do. I'm going to distill that water down, see if there's any good stuff in it, find out how much this contains, then work out the amount of chemicals we're going to need in it. I think I've got enough for one full one, for sure, but I don't know about after that. I might need some more of the zinc sulfate and sodium bromide. We might need a little bit more. But after that, well, we'll see how we go. Oh, what do we want? Yes, we're running. So we just measured out how much water is in here, and there is 1.5 litres of water. Now I'm going to have to go out and calculate how much zinc sulfate and sodium bromide go into 1.5 litres of water. Dear, that's going to be a large quantity. 1.5 litres, 1 mole is what is it? 106 mils or 106 grams of one, and 160 grams of the zinc sulfate, which is 1 litre. 160 grams of that plus a half is 80. I'll have to go and get my calculator, because I've run out of fingers. Yeah. Okay, that's enough for there. Well, we just had a look, and I was wondering why the voltage wasn't coming up. I spread this over the bottom of the carbon, and when I checked it here for continuity with the carbon, there was no power coming through because the copper's all been eaten away. And I know the copper's all been eaten away because if you can see that, it's copper plated on there. So it's chewed up the copper and plated it onto the top thingamajig. And I don't think that's how it's supposed to work. It's supposed to be zinc. Looks like it's added zinc there, right? It's but it also took the copper from down there and plated it onto the top. So that's no good. I couldn't work out why it had no continuity. It's because the cord to the top was buggered. See, if you look there, that carbon conducts right across, yeah? So I've got to find a better method to wire that to the top, and I don't know how I would do that. Would I use nickel? Don't know, but it eats copper. It doesn't do very good for copper. So I've got to find, I don't know if you can see that. Yeah, I don't know if you can see that at all. We'll just loosen that a bit. There you go. There you go. Let's see. So I'll just show you again. If you look at that, that's got copper coated on there. So that means that the copper that was underneath that carbon, see the copper was spread out underneath the carbon, has been eaten away. So that's where our power's gone, because there was no connection between the bottom carbon plate and the wire that came out. So yeah, that's definitely no good. I don't know what to do with that now. I think it's amazing that the electrode doesn't fall off, right? But I don't know. See, we found a little failure there already. You can't use copper in there because it just eats it away. Alright, well, back to the drawing board in a minute. I'll have to change all my mind of what's going to happen here, because got goodness, it just doesn't pan out, does it? Can't use the system I decided to use. I'll have to make a different element on the bottom.